Hi everyone, and welcome to the Target 23 Part 2 homework review. So as always, this Part 2 homework review matches up with the Part 2 worksheet, and we're just going to go through a couple problems from that Part 3 or Part 2 worksheet, try to give you a little bit more guidance on what it's like to find area and perimeter of parallelograms, rectangles, or parallelograms, rhombuses, and squares. And so the problems we'll work through today are number 4, number 5, and number 10. And without further ado, let's just get started. So identify the shape, find the area, and find the perimeter. So the shape in this one is a parallelogram, right? Our options were essentially parallelogram, rhombus, and square. I hope you can look at this shape and know it's not a square for sure. And then the second thing, the reason why we're going to know it's a parallelogram rather than a rhombus is because if you look down at number 5, for example, see how all four sides are the same? That's a property of a rhombus. That is not happening here in number 4. And so number 4, obviously not a square and also not a rhombus because not all the sides are the same. So it's got to be a parallelogram. Remember in the word parallelogram, you see the word parallel. And so seeing top and bottom parallel to each other and left to right, that's important, right? So here we go. It's a parallelogram. Let's find the area. Nice thing about this problem is you actually have all the information you need to answer all three of these questions. You just need to know what to look, how to look, how to visualize it. So find the area. Area of a parallelogram is the same thing as area of a rectangle because a parallelogram is like a slanted rectangle. So it's simply base times height. Remember, the most important thing is your base and your height create a 90-degree angle with each other. And so our base is 15. I think that's decently easy to visualize. But then our height has got to be 11 because that's that hidden line or not really real line drawn from the corner to that 90-degree angle down there. It's completely up and down, and so that's going to be our height. And so again, area is base times height, so that is just 15 times 11, and our answer will then be 165 inches squared. Perfect. And then the perimeter, we just have to add all four sides together. We only know two. We know the 15, which is the bottom, and then this 14, which is a slanted side. But the thing about the parallelogram is top and bottom are the same, and left and right are the same. So if the bottom's 15, top's going to be 15. Right side's 14, left side's got to be 14. And so then our perimeter, we'll just add all that together. 15 plus 14 plus 15 plus 14. And when we add all that together, I believe we get 58 inches. And that is our perimeter. So it's a parallelogram, area of 165 inches squared, perimeter of 58 inches. All right, beautiful. Now, next one. We already talked about this shape. Remember, we highlighted the fact that all four sides are the same. And it's not a square because there's not 90-degree angles in the corners. And so if it's not a square, but all four sides are the same, that makes this shape a rhombus. All right. Now, you'll notice that the diagonals are drawn in this rhombus. You see the lines connecting opposite corners drawn in the middle. And so one thing about a rhombus is the diagonals get cut in half. So if that part of that diagonal is 6, so is the other part. What we don't have as far as diagonals go is anything about this diagonal. We don't know the top, we don't know the bottom, we don't know anything about it. And so remember, for finding area of a rhombus, one of the best formulas is going to be area equals diagonal 1 times diagonal 2 divided by 2. And remember, diagonal 1 and diagonal 2, it doesn't matter which one's which, but what matters is we're talking about full diagonals. So in the blue, remember, part of it was 6, other part 6, so the whole thing is 12 feet. So that would be like one of our diagonals. But we need to know the red diagonal too, and we just don't know it, but we can figure it out. Because here's what happens. I'm going to go back to red, and I want to highlight this. Take a look at this shape I am highlighting right now. I believe you can tell that that's a triangle. And not only is it a triangle, but because that's a 90-degree angle, this side's 90, and it is a right triangle, right? And anytime we have a right triangle and we know two sides, 6 and 10, we can do a squared plus b squared equals c squared to find the missing side. Obviously, our missing side is this part over here. I'll call it x this time. Remember, the crucial thing is let's figure out which one's c, and that's always going to be across from our 90-degree angle, so that's the 10. And so right now, x and 6 are a and b. So we can solve for x by doing x squared plus 6 squared equals 10 squared. And let's find this all the way through. So x squared plus 36 equals 100. Subtract that 36 from both sides. X squared equals 64. And then square root both sides. So x equals 8. So 64 is exactly 8. So that's good. So that's what x is, right? And so I want to start cleaning this up again. I'm going to leave the x there, though, at least to the best of my ability. And so we just found that x is 8, right? But remember, that was just this part of the diagonal. Diagonal gets cut in half by the other diagonal. So if that part's 8, this part's 8. Which means that full diagonal is 8 plus 8, which is 16. And so we now know that full diagonal is 16. We knew the other full diagonal, which I've done in blue, was 6 and 6, which is 12. So now we know both diagonals. So we can use this formula. And so the area of this rhombus is going to be one of the diagonals, let's call it 16, times the other, so times 12 divided by 2. And when you do 16 times 12 divided by 2, you should get 96 feet squared. And that is our rhombus's area, 96 feet squared. I'm sorry, that's just a terrible math. I've got to do better than that. 96 feet squared. Now, the perimeter, we hadn't talked about that yet. The perimeter in this problem, not so bad. The reason is we know one of the sides, and then remember, all four are the same. And so if that top's 10, the left's 10, and the bottom's 10, and the right's 10 as well. And so our perimeter is simply just 10 plus 10 plus 10 plus 10, which is just going to be 40. And the units are feet, so 40 feet for our perimeter. And that's that. Problem number 5 was a rhombus, area of 96 feet squared, perimeter of 40 feet. All right, last one is a working backwards problem. So we have a square, and it tells us the area. And that's it. And we got to find the perimeter. And so here we go. Draw this square. Remember, in a square, we have 4 right angles and 4 sides are the same. Now, for this problem, just for right now, I'm going to call all the sides S. Right? S just stands for side. And I put an S on all 4 because it stands for the same thing, because all 4 are the same, right? And our area is 121 inches squared. Well, remember, there's various formulas for a square. Area equals base times height. But in this problem, base and height are both S, right? And so that's kind of like S times S. And anytime you times something by itself, that's the same thing as that thing squared. And so the area of your square, again, can be thought of in multiple ways, base times height, or just one side squared, one side times itself. And I want us to focus on that formula right now, this one right here. And here's the reason. I know the area, so I can plug that in for A. 121 is going to equal, and I don't know my sides, so it still equals S squared. But now S is all I have to solve for, right? And so it's S squared is 121. So if I take the square root of S squared, that'll leave me with S, and the square root of 121 is just 11. And remember that S stands for the length of a side. And so that just means every side in this problem is 11. This S, 11. that is 11, that is 11, that is 11. 4 11s. And so now that we know that, the perimeter will just be 11 plus 11 plus 11 plus 11. And 4 11s added together will give you 44 inches in this problem. Excellent, excellent. All right, everybody. So that concludes the part 2 homework review. Thank you for reviewing these problems. I'm hoping it's making some sense. We'll continue with this area and perimeter discussion, just new shapes tomorrow, or today, I guess. So please, if you have any questions, please reach out to me and I'd be happy to help you. Otherwise, keep up the great work. Have a great day.